make a game of Breakout. So first, basically what Breakout is, you can actually play this game on Google if you just search Atari Breakout and then go to like images. But basically what it is, you have a paddle. So it's kind of like, I think there's that old game called like Pong or something where you both try to bounce this little ball, which is just like a pixel. But this time you're playing it like single player and you're bouncing it into these blocks that get destroyed as you bounce them, basically. So we'll be like using code in OpenGL. But I think this can apply to anything else. Like you can the concepts in this is more important. So you can kind of learn this and make this game in other forms in other languages of code as well. So the one we'll be making, it will have really good graphics. So if you look at this one, this is like really old. Although they don't even look like blocks, it's just like straight lines. And the paddle is, or the ball is just like 1 pixel. So we're gonna improve off of that. So before that, I'll just show you what Breakout is if you've never seen it before. So it looks like this. This is the Google one. So I'm not trying to let the ball not hit the paddle because, okay, I'll just show you. If it does do that, you're gonna lose a life up here. It went from 4 to 3. Um, and this version of Breakout on Google, basically your goal is to hit everything without losing many lives. And then if you hit the top ones, it goes a lot faster. So yeah, this is just a demonstration of the game. Okay. So I'm gonna go to setting up. So first of all, we obviously have to make the window for the game. And this just has all the necessary code for that. It's going to kind of like a pop-up. So if you click on like an application like in your computer, you get like a separate window for that. So this is what all of this code is going to create. So we'll probably send this website in like the GitHub or something, and whenever we update that. But you can also look through these on your own. Basically, we make the size of the window, and then we initialize it that way. Okay. So the utility stuff, unlike the regular Breakout, you can actually add like shaders and textures to these. So they have all the code for this. Basically, you can make the background different colors, have different textures, and all of that. Okay. For like resource management, this is still on like shaders and textures and stuff. It's just improving how the game looks, how the window looks, like changing the size and stuff. Okay. So this is basically the program. If you run this in OpenGL, it's just gonna give you a blank window, and we can make our game in that window basically.
Wait, Lucas, really quickly,
Yeah.
can we take a photo right now for
Okay.
this to
Yeah, I
open?
think we could take
All right.
photos.
Can you stop sharing?
Yeah.
Yeah. So, right now, can you guys turn on your cameras? We're gonna take a quick photo. We have like some people who are late, but we'll just take a photo with those who are here with us now, and in that way, we don't need to like wait for the late people. We can like submit a different one with them in there too, if that makes sense. Uh, Andrew, are you here? Okay. We'll wait like 1 minute for Andrew. If not, we'll just. Oh, Andrew. Wait. Yo, Devin, are you, once Devin gets in frame, I think it'll be good. Yo, Devin, hello. Okay. All right. Yeah, we're good now. You guys can turn your cameras back off. Sorry, I didn't give a countdown, but yeah, I took a couple of screenshots. We should be fine. Oh yeah, and Lucas, you can continue again.
Okay, those are I don't know if Eric said this, but those are for your book, by the way. We're not just like taking pictures of you randomly. Um, okay, but next I'm gonna talk about rendering sprites. So it is still gonna be like a square or a ball that we're bouncing, but we're gonna use like the coordinate system to to project it, and we can also you see here how it's not just one color; it's actually like a shade of different colors. We can customize that. Okay, so it's not too complicated, and since Breakout is a 2D game, we don't have to worry about cameras at all. So it's just the projection. Um, so normally in like other games that are more complicated, you have to position the camera, which is basically where you're looking. But here we can just simplify it down to like a 2D projection, so we don't have to worry about where the camera is pointing. Okay, so in OpenGL or in OpenGL, the coordinate system is like this. It's 0, 0 in the center, and then the 4 quadrants are around it. Okay, so we can uh, make a sprite like this, and if you read this code, you find that if we made this, it would be located in this location or these coordinates. So that's like how you would render a sprite. Okay, all of this talks about just like initializing the sprite and then rendering. Uh, so okay, the transformation stuff or rotating it is a little bit more difficult. So obviously a square wouldn't be just like always on the same side if it was bouncing. So to make it more natural, we have to make it spin a little bit every time it hits, and make it spin at the right angle. And we also have to remember that since this has different colors on each angle, spinning it isn't it's not symmetric basically. That's what I'm trying to say. So spinning it is a little bit harder, but it looks a lot better when it's not just a square moving vertically and horizontally. All right. So this is the example that they came up with. This will basically make a sprite that's a happy face like this. And notice how we did manage to make it not up just like boring and upright. It's actually diagonal. So that's part of rotating. All right. Okay, so you can see at the top, breakout is unfortunately not just about a single happy green face. It actually has levels, and we're going to make those. But making that happy face is part of the start is like a big part of it. We can render the sprite. So now we just have to actually make the game and the mechanics and stuff. Okay, so using the same like sprite logic, we can render these squares. So this is how our breakout game is going to look. These are the squares. Uh, and we can use units like this to show that. So um, when there's a 0, that means there's no brick. So notice how there's no brick in these two squares that are in the center. When there's a 1, it's a solid brick. Basically, it cannot be destroyed because otherwise, I think the ball would just like go off the screen if we didn't have these solid bricks. And then a number higher than 1 is a destroyable brick, and then it has different colors. So as you could probably see, 2 represents blue, 3 represents green, and then 4 represents yellow, just in this case. Okay, so we are going to initialize the level with all the bricks and stuff. And then the textures. So a lot of the code in this, it looks really complicated, but it's just copy and paste of the textures and stuff. The main, I think, concepts aren't like that hard. Like the coordinate stuff, that takes up a lot of the code. That's why. Okay, so after doing all that, we would have something that looks like this. It's more complete. It has a lot more bricks. And if I were to write this as these numbers that we see like up here, um, obviously these would be ones. The empty space would be zeros, and then the different colors would all be greater than 1 with different colors. Okay, so the paddle, in the Google Atari that I played, it's a rectangular thing, but we're not gonna make it look that boring. So we're gonna give it some texture, make it look like an oval. All right, so we're gonna get a game that looks like this. We have a paddle, we have a functioning squares. If you hit the ones that have stripes, they're not going to be destroyed. Your ball is just going to bounce off. But if you hit the other colors, they will break and your ball will bounce. Okay, so that's it on the levels stuff. So I'll pass it off to Josh.
Alright, so we're going to move on to the topic of collision. So that's basically how the game mechanics works, with how the objects will interact with each other. And now, before we get started with that, let me ask you guys a quick question. Assuming we draw, oh god, assuming what? Assuming we draw a rectangle like this, and I ask you to pinpoint where 0, 0 is. If I told you to point out where the coordinate is 0, 0, assuming this is your screen, where is 0, 0? If you want to try to answer that in chat. Yeah, so some of you might, if you're in math, you probably would guess that 0, 0 is the bottom left if you're looking at this like a 2D coordinate plane in the first quadrant. Or you might say that maybe 0, 0 is the middle of the screen and you're looking at it as a 4-quadrant coordinate plane, 2D coordinate plane. But I'd tell you that all of these answers are actually incorrect. 0, 0 is in the top left corner. Oh, wait, hang on, we have to read chat. Oh, we're taking another picture at the end. Okay. So we have the 0, 0. The top left point here is 0, 0. So in programming, usually 0, 0 will refer to top left corner. And if you think about it, it also kind of makes sense, I guess. If you're drawing 2D arrays and you're referring to 2D arrays, the 0, 0 is also top left. If you write out 2D arrays, so for example, if we make a 2x2 2D array, we can do like maybe 0, 0, 1, 1. In that case, this element right here will be referred to as 0, 0. This will be the 0, 1. This would be 1, 0, and this will be 1, 1. So 0, 0, if you lay it out, most people like to write out 2D arrays in this sort of fashion. So it creates sort of like a 2D shape that you're more familiar with. And you can see the top left corner is the first element, and that element will be 0, 0. So 2D arrays also follow this kind of format if you want to write it out in more of like a visual method. So, oh, shoot. Let's ignore that. So now, once we have established where 0, 0 is on the screen, how do we actually create objects to move across the screen? So we want to think about the logistics first. And the first thing we want to discuss is the ball. So the ball in Breakout, you can probably notice it bounces around the screen. But how would you make the ball bounce? Well, there's different methods you could take about this. You could change the position manually every time you move the ball, or you can introduce velocity. So velocity is basically the speed and direction at which an object will move. So for example, if we say that let's just do a simple one. Let's say we're on 2D limit line and we have an object at the very middle. If we say this object has a velocity of 5 meters per second, it means it's traveling this way at 5 meters per second. And if we're saying it has -5, then it'll be going the opposite way. And so what we can do is introduce the concept of velocity into our ball. So then our ball, every frame of the game, the ball's position will change by a certain velocity that we'll input. And so every time the game updates, we'll just change the ball's velocity by a tiny bit until it starts moving. And yeah. And how do we know if it hits a wall? Well, we have to compare the ball's position to the screen's position. So if we have a ball here at the very left edge of the screen, the ball's position would be something like 0, something. It'll be something, depending on how high up and down it is on the screen. So because the origin is 0, 0, means everything on the left here is 0 and everything on the very top here is 0. So if the ball moves left past the screen, then the x coordinate will change into a negative number. So negative, say 3, and then the y coordinate. And we don't want it to go off screen. So once the ball hits 0 or any number underneath 0, we want it to flip the velocity around. So instead of going left, we want it to start going right. Just bounce it off the wall at a 90 degrees angle, or not 90 degrees, so just bounce off the wall. And to do that, we have to compare the ball's x value to the number 0. So that's very simple. You just do a very simple comparison. You just check whether the sprites, so it's like sprite.x or this.x if you're referring to the sprite itself, is less than 0. And if it is less than 0, that means it goes off screen. Then you just flip the velocity around. So you flip the velocity, so it's traveling the opposite direction. And then you continue on your merry way. And also another thing you want to make sure is that you set the sprite's x back to 0. So after you set velocity, you also want to remember to put the sprite's x position to 0. Because if you think, if your velocity is high enough, then there might be a time when your frame or your ball will move by more than 1 pixel or one position at a time. So it might go from x equals 1 to x equals -1. So if you were checking for, say, sprite x equals 0 instead of less than 0 or less than or equal to 0, then what might happen is it might skip over the number 0 and then cause it to not bounce. And now your sprite is off screen and everything's bad. So you want to make sure it's less than 0. And if it does go into the negatives, to put the ball back on screen and put at the position 0. That way it doesn't go off screen and disappear into like oblivion. So that's the left side. The right side is pretty similar. You'll be using sprite x, but instead of checking it against a certain number, since you're not really sure, you want your code to be a variable. You want it to be able to adapt to different situations. So we don't know how big the screen is. We don't have a set position. We can't just say it's like 1080 or whatever. We can't do that. So instead, what we do is we use variables to store the screen's position that we can get back from it later. So in this case, we can store it as like screen width and use that in place of the actual width of the screen. So then we check whether the sprite x has become greater than the screen x, which means it goes off screen this way. And now another thing to take note of is how big your sprite is. So say your sprite is small as compared to big. Well, the small one, you will see it could travel from the left screen to the right screen of much more than the big ball can, because we want it to bounce off the wall. So we want it to look like this, where the small ball is like that, and the big ball is like this. And you can see the small ball is allowed to move further right than the big ball is allowed to move. So the big ball, so the size of the ball will have to be taken into consideration when you're bouncing the ball off walls. And the bigger it is, the less you can move. And what we want to do is we want to take the radius of or the size, I mean not the radius, the size of the sprite, and you want to factor that onto sprite X. So then you have the X position, where the position is, and you add on the sprite's width so that you get the edge of the sprite and make sure it actually bounces off the wall and it doesn't become something like that where it's off the screen. So then you can take sprite X, you add in the sprite's width. I'm going to start abbreviating here, and you compare that against the screen's width. And the same thing, if it's over, which means it's past the screen, you want to change the velocity to negative, so it bounces off. Instead of going this way, you want it to go that way. Just flip the velocity around, and same as always, you want to set the sprite's X to the maximum number, which is screen width minus sprite width, to move it back on screen if it goes off screen. And it's getting kind of messy. Just delete some text. And now the final place you want to bounce off of is the top. So top is very similar to the left side. It's just it's just sprite Y instead of sprite X. So the sprite's Y position, and you check whether if it's less than 0 or not, which means it has gone above 0. Remember, top is 0, bottom is like screen height or whatever you want to call that. And we don't actually really care about the bottom, since if it does hit the bottom, it doesn't bounce. It just commits not alive. You lose a life. So the bottom, you don't have to check for these bounce collisions, and you don't have to bounce the ball. You just need to bounce off the left wall, the top wall, and the right wall. So this is the logistics that go behind our ball thing, our ball bouncing mechanism. And to actually write that in code, I have it saved up in the top left over here. The first thing we want to do is create the ball object. And that one basically is sort of like a game object. So you can just copy off that. So you got ball object and then game object. You want to declare two different variables. You have the radius, which is the size of the ball. And that way we can draw the correct one. And also we can use that in our calculations for bouncing off walls when you need to take into consideration the size of the ball. And also stuck. So stuck is a different variable. The stuck variable refers to whether it is being held onto by the paddle. So if you remember when Lucas did the demonstration of the Atari Breakout on Google, the ball remains stuck on the paddle for the beginning until the user releases it, or at least we're going to make it so that it stays on until the user releases the ball. And so we need a Boolean stuck to ensure that when it is on the paddle, it doesn't move around randomly. It doesn't start bouncing off walls, even though the user hasn't actually launched the ball yet. So that's going to be our Boolean stuck. And these are just to create the game object, the ball object again. And now after that, put on the side, make it smaller. The actual mechanism for a bouncing ball comes into play. We need to create a function move. So every time it's called, we'll move the ball a certain amount. Now dt stands for delta time. So that basically refers to the time it refers to the time that passed before the last update, or since the last update. So usually games will have this to ensure that everyone, no matter what their frame rate is, will run this game at a constant speed. So it won't like suddenly speed up to like 1,000,000 frames per, or 1,000,000 like miles per hour once you increase your frame rate. You want to make sure you have constant. So DT is usually used to ensure that no matter what your frame rate is, the progress of the game remains relatively the same. It might not be exactly the same, but it'll try to be relatively the same. So just the time since last update. And then you will update the ball by taking in its X position and its velocity, its X velocity. So you're gonna have two velocity, one for X, one for Y, and you wanna change them. So this one, so the velocities, they're stored in, I think, 2D vectors. So you can have X and Y coordinates. And when you just add velocity to position, it'll add the X and Y for you. So that's why it's a one-liner. And you multiply delta time to see how long it has been passed since the last update. So if, let's say you were running maybe 2 frames per second, and let's this sounds stupid, but let's say you're running 1 frame per second, then every update, it'll update by, hang on, let me write this down. If you're running at 1 frame per second for on like a really bad computer, then your game will update once every second. Every second it will draw a new frame, right? So your delta t will be 1. And so let's say if your velocity was, let's do it easy, now let's do 5, then it'll multiply 5 by 1 and you get 5. So the velocity is still 5. Let's say you go 2 FPS. Now it will draw 1 frame every 0.5 seconds. And so delta time will be 0.5. Your velocity is still 5. You want to keep the same velocity. And you get 2.5, which means every time it updates, the ball moves by an increment of 2.5 instead of 5. And now that will ensure that they actually move the same amount. Since if you think about it, if every second it moves 5 units, while in the smoother one, the faster one, it moves 2.5 every half a second. So in 1 second, it'll move 2.5 plus 2.5 is 5. So it'll move 5 steps. So then they match up no matter what your frame rate is. So that's the y you multiply by dt. And now after that is just the logistics that we already mentioned before. You check whether the ball's x value is less than 0 or if it's greater than the window's width, including its size. So you have to take in consideration the size. So that's over here. And you do the same thing for y. And so this is the mechanism. How much? Oh, it's 102. Or do you want to take the picture now or?
Yeah, sure. We can take it now or we could take it at 110. It doesn't really matter too much. It's up to you. Your
I'm
status.
almost done. I don't have. Let me show formal pictures.
Yeah, cool.
Yeah. So after this, you have to basically put the ball into the game. Oh yeah, this is how you would phrase this. I'm not sure if I phrased it correctly, but you create a ball object, or you create a new ball object. You create a ball object in your game and you put it into your game. So that's this part. And down here, you also texture it. So remember the face texture, the happy face that you showed earlier, that's this one. So you want to put in the texture. Just move that smaller. And now after that, remember the one we made earlier over here, this is a move function. So you need to actually call it. So every time the game updates with a certain amount of float dt, so it will provide you the time it takes, you will pass that into move. And the dt will also be passed so that you know how long it's been since the last update. And then it'll actually make the ball move. And then it'll also bounce the ball whenever you need to, since that's also included. And then after that, what we need to do now is we need to check basically the keys. So now we're implementing the player actions, I guess. So depending on what key they press, you want the game to respond in a certain way. So for A and D will move the paddle left and right. And then this will also affect the ball. Since if you think about it, the ball, when it's being held by the paddle, it should remain in the same place relative to the paddle. But that means the ball will also move left and right when the paddle moves left and right. So to ensure that they are actually in the same place and the ball isn't getting left behind, you have to update the ball's position by whatever your paddle changing. And since we're using velocity, if the paddle changes by say 3 meters, then the ball will have to change by 3 meters. That's a huge number. I don't know why I came with that one, but that's why you add in the paddle's velocity to the ball when you're moving the paddle. And the same goes for D. When you change the paddle's position, you got to change the ball's position to make it look like they're stuck together. And then after that, if they hit the space bar, that's for the releasing the ball. So you change the variable or the Boolean stuck into false. So now the ball is no longer stuck and now it's free to move on and bounce around the field. And now, remember, last thing to do, since we're working with drawing and rendering and buffer frames, we have to actually render the ball. So we'll put the ball on and then we'll actually render it. So this is the important part. Don't forget this one. And yeah, that's it. This is how you kind of add in your ball to your game. I think we'll stop here since we're kind of running out of time to continue on. And I'll pass it on to Eric to deal with the pictures.
Yeah, cool. So, can we just do the exact same thing? Everyone just turn on the cameras, a snip a quick screenshot, and this time I think we can all leave because it's the end of the meeting. I think we're missing 3 people. They're just missing action, I guess. So I think we'll wait 1 minute. Otherwise, I've snipped a screenshot of those of us who are here. So it should be good. Now we're just waiting for Andrew. Wait, first, Andrew, are you here? Can you like message me if you're here? All right, I'm gonna take a picture right now. Okay, and then I think we're gonna leave. I assume Andrew is not here right now. And then thanks for coming, guys. I'm going to end the meeting because I'm assuming we're good.